Hello, this is Chase, and Sarah and I are going to be talking to you today about hydration of an alkyne. It's going to be a really fun reaction, and we hope you enjoy it. So we're going to start with step 1, and in this step, the alkyne is going to attack the H+, and the H+ comes from any acid you want. And the reason the alkyne does this is because it's very dense in electrons, and it's going to add to the less substituted carbon, which means the one with more hydrogens on it, because it forms the more stable carbocation. In step 2, the carbocation is still very unstable, so the water is given a chance to attack it, and it forms the water as a substituent on the carbocation. So now we have an alkene with water as a substituent on the carbocation. So now, step 3, we're going to keep going, and the oxygen is actually positive now because it lost its electrons to that carbocation. So now it's going to make a hydrogen fall off in order for it to be more stable. So this is that process now, and we end up with an OH group with 2 lone pairs because the hydrogen donates to the oxygen. Step 4, we're going to have the alkene actually attacking, and it's going to attack another H+, and it's going to add the H+ to the less substituted carbon, so it's going to end up with CH3 and another carbocation in the same place as it was before. Now, with step 5, we actually have a resonance form that's a lot better at reacting than the other form, so it's going to move to that resonance form, and we're going to show that happening now. So remember, we've got the carbocation, and we've got resonance here. The oxygen is going to attack the carbocation to make the oxygen positive, and the carbocation is going to end up being neutral with a double bond. And remember, we still got that hydrogen on the oxygen, so the last step is actually just that hydrogen coming off. So we have step 6, and the hydrogen is going to come off, and again it's going to donate its electrons to that oxygen to make it neutral. So the hydrogen's happy, the oxygen's happy, and we end up with a ketone. So remember, we got 2 forms in this reaction. The more stable one is the keto form, and then the enol form is the less stable one. So we're going to review a little bit. First, we have H+ coming on, then we have the hydration by the water, then H+ comes off, H+ comes on again, resonance, and then finally we have the H+ coming off to make a stable ketone, and that is the hydration of an alkyne. So let's see what Dr. Amos has for us today in jokes.
Hello everyone. Welcome back to Organic Chemistry. So, why did Dr. E put his tooth in a beaker? Answer: because he wanted to make a 1 molar solution. Ha ha ha! Molar! Ha ha! That's a good one.
Thank you, Dr. Amos.